Hey everyone, so I'm back and this is a little bit late, but this is the video for this week in physics, which was the black hole image that was released some time ago, like 2 weeks ago or something. I was away for a little bit. So this is about the first ever black hole image that was released, and that is the image, okay? Now, I know it doesn't look much, but it's actually quite a big thing, okay? Now, what about this image? What can I tell you about this image? So it measures 40 billion kilometers across. So that's 3 million times the size of the Earth, okay? So that is the size of the image, okay? The black hole is 500 million trillion kilometers away, so it's quite far away, and it was captured by the Event Horizon Telescope, also known as EHT, and that is actually a network of 8 linked telescopes, so they have it in different places on the Earth, and they all were linking together to make this huge image, okay? Because when you get the telescopes from different points of the world to get the same image, it is actually the same as a huge telescope within the distances of those different 8 telescopes, making one single image. So you make your telescope much larger. Now, the black hole was found in a galaxy called M87. And what we can see in the picture is larger than the size of our solar system. So this is for you to have an idea. And again, this is what we can see in this on the picture. And this picture was taken over 500 million trillion kilometers away. Okay. Now the mass is 6.5 times the mass of our sun. So it is quite massive. And the bright halo that you see is caused by the superheated gas that is falling into the black hole. And the light is brighter than all the billions of other stars in the galaxy combined. And again, it might not seem like it just by looking at a picture, but this is actually why they decided to picture this black hole and why we can actually see these images even though it's so far away. Now, the edge of the dark circle is at the center is the point where the gas enters the black hole, and nothing that enters in there can escape, not even light, okay? Because the black hole has such a large gravitational pull because it's so dense. So this is, and it's going to be in the next slide, the event horizon, okay? And then one of the commentaries about this image of the black hole, it is that maybe, or it seems like Einstein is right again, because what we can see from the image is actually similar to what we obtain from calculations, theoretical calculations, where Einstein was putting his input in, okay? So it does look like, again, over 100 years after, Einstein is correct again, okay? Now, what is a black hole? Because people are taking this picture, but what is actually a black hole? Now, there are 2 types of black holes. So one is the stellar black hole, and they are the supermassive black holes, okay? But, overall, a black hole is a region of space from which nothing, not even light, can escape. That's the name black hole. Now, it's not that it's empty, it's not a hole, but instead it consists of large amount of matter that was packed densely into a small area and gives it an immense gravitational pull, such a big gravitational pull that, again, not even light can escape. That's why it's called black hole. And this is because of matter that actually collapsed into the black hole. So, for example, if it was from a star, a very massive star that when dying collapsed and made this black hole, or it could be a combination of other stars, or even more than a black hole, but this is something that could be in another video, okay? And this is what makes that all that matter is packed in a very small area and therefore is quite dense. And then there is a region of space beyond the black hole called the event horizon, and this is a point of no return. So what happens? Beyond this point, it is impossible that anything, even light, can escape the gravitational effects of the black hole. So if you have a little bit of matter going around the black hole and is further away than the event horizon, is not going to fall in there. But if it's close enough, it's going to fall in there and it will never come back. Okay? So this is the black hole, and of course, with this image, there were lots of different memes and stuff around the internet, which were quite funny. But I just want to finish the video with the person that actually took this picture, or the person that made this picture possible, which she's called Katie Bowman. I hope that I said it well, Bowman. And she was an MIT graduate student, And she actually made this algorithm that was possible, or they made possible, to produce this image of the black hole. And she learned about the imaging project in high school and decided that she was going to do that. So she decided that in high school that was her goal. And again, she actually made the algorithm while still in grad school. And today she was able to take the picture of the black hole, of course, with, lots of people helping her, but that's a teamwork. But this is her, so there we go. And I believe this is it for today, and yes, it is. So up to my next video, which hopefully is going to be the answer for the last riddle that I gave you. Up to my next video, be happy and healthy. Bye!